be Dwane Young from the EPA's Office of Water Data Integration. So a couple of housekeeping things real quick. Everyone is using computer speakers for the audio. You can interact with us as the speakers by using your chat box to submit questions, and I will be asking those questions aloud during assigned breaks during Dwane's presentation. And then following today's session, please fill out a very brief survey that will be sent to your email and give us feedback for our next time doing a webinar. So a little bit about River Network. If you're joining us today, you probably know a little bit about who we are, but if you're just discovering us for the first time, River Network's been around for about 29 years, have a bit of a unique niche in the community where we serve the broad network of about 3,000 different groups and organizations that try to do clean water work on the ground. We take a kind of a multifaceted approach to this, both by just trying to empower and improve the network by exposing them to some of the best resources and practices that are out there in practice within the community. We also develop some hands-on training, do some one-on-one assistance. We take occasional regional deep dives in certain areas as well. So today is just about that first part, about trying to make sure that people in the network are exposed to some of the best practices and resources that are out there. I would be remiss if I didn't mention that River Network is a membership-based organization. There are a multitude of benefits that come with membership, and I will say before getting into too many details that we are taking some big changes in our membership program, to stay tuned for those, and they're supposed to launch in January of next year. Additionally, one thing that we are known for well within the community is our annual conference, which is River Rally. If you haven't been to River Rally before, start thinking about this next one in 2018. We're going to be in Lake Tahoe, California. The dates are April 29th and May 2nd. And again, I think registration for upcoming River Rally is going to be launching within the next month or right around the first of the year. So stay tuned for that as well. So today's agenda, what we've got coming up, some brief acknowledgments, who's sponsoring these webinars and the general science resources we're trying to provide with folks. We're going to dig into a little bit of background about the community science framework that exists for water data, and take a look at what that framework looks like and how this tool fits into that, and how that you can get on that framework and start to discover and start to use some of the resources that are available for doing citizen or community water science. Towards the end, we should hopefully also have some time for questions and discussion. Again, we'll also try to get to a couple of those as we go along. And of course, at the end, we'll be closing up for a survey. So our webinar today is sponsored by the Pisces Foundation. Pisces Foundation supports River Network generally in our science support programs to connect and empower our network with today's best clean water and citizen science resources, practices, and technologies. As part of this, Pisces Foundation has started an ad hoc collaborative working group formed primarily from some of the folks that they're funding that work on citizen science resources, and also some of the key players like Dwane that are out there have created really useful resources for the water science community. We're generally loosely charged with collaborating on some of the citizen water science infrastructure with the goals of trying to identify and prioritizing gaps and strategies for improving those resources, and really trying to increase the adoption of these technologies that are starting to come out by citizen scientists and citizen scientist groups. Overall, we want to increase the quality and the utility of citizen data and increase the amount of data that is getting into the open data platforms. And we'll talk a little bit about that and the power that comes with those. And we have a big focus on low-cost or open technologies and platforms as well to make sure that these solutions are affordable and practical for our citizen groups. So this slide, I hope it doesn't look too complicated or you're able to see some of what's going on here, but this is the framework that we're using collectively within our steering committee to help us really navigate what's going on in the citizen science world. It's useful because it allows us to conceptualize both the overall process and some of the existing resources that are currently powering water monitoring and citizen or community science. We found it's been very helpful to be able to see how what is a very complicated process that has many moving pieces is pretty connected, and that those connections are strengthening. And we're using this with funders and service providers in the hope that we identify gaps and barriers that are currently existing in this framework, in the attempt to try to improve resources and communication of those that are producing those resources, and communication of the resources to the practitioners on the ground, make sure they're getting adopted. I'll step you through what this looks like real quick, not to take up too much time, and if you're interested in taking a closer look at this, you can contact me and let me know. But this is basically the framework that anyone who's involved with monitoring can probably find themselves along. And starting up here in the top left of step 1 is all the preparation that someone does to be able to complete a monitoring program for data collection. You know, adequate study design, data quality and management design, program evaluation design, all the tough work that happens in the office before you get out into the field. Step 2 is where monitors collect data, often producing paper data sheets or maybe making use of apps or getting lab reports from samples they collected. Step 3, all groups have to do local data storage. They may be just using spreadsheets and Excel. They may be having relational databases or using an online database of some sort. And again, the idea is that they want this data to then help them get what they want to do done in the watershed. And so there's steps for analyzing, visualizing data, modeling and processing that data, so that eventually you get over to step 6, which is data to action, and you want to communicate the good science that you performed with your stakeholders. You want to share the data itself with products or information or analyses from that data with respective other users like your state agencies or county agencies. And you want your information you're monitoring to help you do science-based restoration and prioritization for your watershed. Now, I want to draw your focus up to the green box up here, because these are the open data initiatives, and it's kind of a focus of what we want to talk about a little bit today, because there's a lot of power in these open data initiatives. And in general, the Water Quality Portal is our big portal here in the U.S., in North America, where a lot of this data is ending up. And today we're going to be talking about something that's kind of in the box on the right, which is where these tools are really coming into their own. Now that we've collected a lot of data in these portals, and because they're based on open data initiatives and they're open to outside developers, we're starting to see online web services be created that can use the data that's in there and do additional analyses and produce powerful results for folks. So in some sense, you could skip many of these steps along to the data to action if you can get your data into one of these open data initiatives and then take advantage of the tools that are starting to be built on top of them. For more information, you can come to our website, where we are starting to track and catalog a lot of the resources that you might have seen in some of those boxes. For a more detailed look, you can come and then explore the resource pages there. There's a lot of coming soons for parts we haven't gotten to yet, but if you want to navigate there, it's our work, clean water, how we help, and then providing science support. And with that, I'm going to go ahead and introduce Dwane Young, who's the Chief of the Water Data Integration Branch from the US EPA Office of Water, and he's here to talk about the Water Quality Portal Data Discovery Tool.
Okay, great. Thanks, Adam. Appreciate the time to be here on this webinar with everybody to tell you a little bit more about the Water Quality Portal and some of the tools that we have been developing to help people interact with the data that's in the portal. Let me get my screen shared out. All right, Adam, I just want to check. Can you see my screen?
Yeah, it is coming up now. Thank you.
All right, perfect. Okay, so today's going to be a little bit of presentation, a whole lot of demo, and hopefully some opportunity for you guys to ask some questions about what we've got going on here and some of the things that we're building out. So I'm going to talk about the Water Quality Portal and the data tools that we've developed for interacting with the Water Quality Portal. But in order to kind of get you there, I need to give you some intro into what the portal is, where it comes from, where the data come from, how data can get into the portal. I'm going to introduce you a little bit today to the concept of a web service, and then I'm going to talk about these tools that we built and what it is, the intent of these tools that we built. I'm going to demo to you what we're calling our data discovery tool, which gives you the ability to interact with data in the portal and discover what data are there and then export that out into formats that you can make use of. And then I'm going to walk through some screen grabs, potentially, depending on how brave I feel today. I might do a demo of what is our data analysis tool. The data analysis tool, what the intent of that tool is to take data that you get from the data discovery tool, and it compares it against water quality criteria or any other type of benchmark that you want to compare that data against to give you a number of exceedances, et cetera. So this is definitely a beta tool that we've been working on. We do have it available out there in the GitHub for people to download and play around with, but definitely keep in mind that it is a beta tool. At the end of today's presentation, you will see a whole series of links that can take you to any of these tools that I'm going to show today as well. And then I'd like to also just kind of close out with where we see these tools going in the future. We're trying some new approaches with these tools. We're really not trying to build tools that are going to be the be-all, end-all for anybody, but really rather stepping into an open source community approach where we build base tools and then we put them out there for the community to play around with and or add capability to, with the hope that they will then also share out their added functionality with the rest of the community as well. So it's a new approach for us, and we're hoping that that will work out quite nicely. So first of all, I want to talk a little bit and go all the way back to how do we even get data in the portal in the first place? Where does all this data come from? So just to give you a little bit of history on what the Water Quality Portal is, the Water Quality Portal is a combined project between EPA, the USGS, and the National Water Quality Monitoring Council. And what we do with the portal is we take all of the data that gets shared with EPA through the Water Quality Exchange, and then USGS takes all of the data that they have in their National Water Information System, or NWIS system, and we map them to a common data model, which is WQX again. And we also map everything to a common set of terms as well, so we're all using the same language for how we describe different parameters that are being monitored. And all that goes into the Water Quality Portal, and then what the Water Quality Portal does is it exposes all of that data using a very basic web interface, but where the real power to the portal comes is that it also has underneath it a whole series of web services that help power the ability to interact with all of the data that's within the portal. So what? People, when I say that, people say, okay, well, what does that mean? What that means is that it allows anybody out there who has a little bit of programming capability, gives them the ability to interact with data in the portal directly through these web services, meaning that they don't have to go to the Water Quality Portal website. They don't have to use the Water Quality Portal web forms to query data and to interact with data. They can build their own tools to retrieve the data and start to analyze it or manipulate it in whatever way they want. And where that becomes really powerful is then with those tools that they develop, they can give their users input parameters that they can modify or variables that they can modify to help them find different sets of data that they're interested in, and then retrieve that data from the portal using those different parameters that they are interested in. So it gives them really the ability to customize exactly what their user wants in terms of data retrieval and data analysis. To get data into the portal, what we recommend to folks is that they publish that data, and we like to use that term publish. They publish the data through the Water Quality Exchange. And what the Water Quality Exchange is it's really just a standard method and a standard data format for publishing water quality monitoring data. So it defines all of the data elements. It defines which of those elements are required under which conditions. It defines all of the pieces of metadata that are necessary for somebody else to be able to understand your dissolved oxygen reading. And it also provides the technology for being able to send that data to EPA. Two methods for sending that data. You can either do it directly through WQX, which is really meant to be an automated way. So if you have a database of some sort and you can map that data to the WQX data model, then you can set up an automated procedure where it says, okay, every month send the change of data to EPA through WQX, and you can basically have that be a hands-off process where your database is going to do that automatically. The other process, which is a little bit more of a manual way, but tends to work better for people who don't have their own data management systems. Maybe they're managing their data in Excel, which we find is actually pretty common. What you basically do is within WQX Web, you teach WQX what your Excel file looks like. You tell us what the columns are. You tell us what order they're in and how those columns map to the WQX data model. and then you upload your Excel file, and it transforms that into a WQX file for you and then submits it to EPA as well. And then once that data gets into EPA, then we send that data into the water quality portal, and we do that twice a week. So you could send your data to us on Monday, and by Thursday of that week, your data would be available in the water quality portal. And then just so you can see there at the bottom is the URL for the water quality portal. So what is the water quality portal? It really is this one-stop shop for water quality monitoring data. So it's a great location for really finding who's collecting data around me or in this area that I'm interested in. And it also provides a forum or a location for you to be able to publish your data as well. Currently, it contains over 343 million water quality results collected at 2.5 million monitoring locations. It's a significantly large data set. And just to give you some context in this has been growing so rapidly that every single time that I have to give this presentation, I always need to go and look and see what the number of results in the portal are, because it changes so quickly. Just to give you some context on that, about 3 months ago, I was giving the same presentation, and I had at that point just updated it to 300 million. So we have grown by 43 million results in that 3 to 6 month time period, which is incredible. Back when WQX was first released, which was back in late 2005, 2006 timeframe, we had 15 million water quality results that were shared through the Storette warehouse at that time. So we've gone from 15 million to 343 million in that 10 to 12 year time frame, which is phenomenal growth. Additionally, the water quality portal provides this common terminology between USGS and EPA, and like I said, this is a partnership between us and the National Water Quality Monitoring Council. How do you get data from the portal? The portal has a very simple user interface. You go to waterqualitydata.us, and I'm going to show you that here in just a minute. You can get data in any of a number of formats. You can get data back in Excel, you can get them back as tab separated, comma separated, you can get KML files that you can open up in Google Earth. You can also get them back in WQX format, which is the XML type format that is the basis for everything. Most folks don't get it back in that format, but there are some values in that format as well. So what I'm going to do just quickly is I'm going to hop out of my presentation. I'm just going to show you just quickly what the portal looks like and how you can interact with it and download data. And then I think what you'll see is I'll show you how we get from this point to the data discovery tool, which is I'm going to show you here in a little bit. So I'm just going to go to the portal website. When I get to the portal website, it's a very basic, very simple website. There's honestly not a lot to it. There is some basic instructions, including a user guide that you can see. There's some information on uploading data, which talks about WQX. There's background information on the web services if you want to start building tools against the water quality portal. You can look at what the results are nationwide, so you can get a sense as to what's the concentration of data nationwide, so you can look at that as well. But I'm going to go ahead and go straight to downloading some data. So what I'm presented with is a form. Some people love this form. Other people are confused by this form. It is meant to be very, very basic. Each of these boxes is a different parameter by which you can query the data. So it's a different variable that you can use to determine what exact data set you're interested in. You can query it by location, either by a state or a county, or within the distance of a lat-long point, or within a latitude-longitude box. You could also query data by site type. Maybe you're interested in rivers, maybe you're interested in lakes, maybe you're interested in groundwater. If you know the organization that is collecting the data, or maybe you're interested in your data, you can query it by the organization identifier. That's who owns the data. If you know the actual ID for the site, you can query by that. A very common way that data are queried within the system is by the hydrologic cataloging unit, or the HUC. So if you know your 8-digit HUC, and this is what I will use almost all the time because I have favorite ones that I like to look at, you can just type that in, and that's an easy way to get access to your data. Additionally, you can do queries by the sampling parameters. So if I'm only interested in water or sediment data, I can use it by sample media. I can do it by characteristic group, which is a way that we have grouped the different parameters that are being monitored. So if I'm interested in just nutrients, I can just pull nutrients data, or just metals data. You can go in here and do that through the characteristic group. characteristics is a little bit more detailed. So if I was interested in just nitrate data or just pH data or just dissolved oxygen data, I could come in here and select that. I'm going to skip these other two because they're a little bit more detailed. And then probably most critically, you can set the range of the date ranges that you're interested in. So if I'm interested in just the last 5 years worth of data, then I would come in here and I would say I just want data that's been collected since 2012. So that gives you the ability to specify what date range you're interested. There is data in here going all the way back to 1900. So there is some fairly old data in here. Most of that is USGS data, but there is some old data in here. So what I'm going to do, just so you can kind of see how this works, I'm going to go ahead and do a query. I am going to do it by the 8-digit HUC. When I do the data discovery tool, I'll show you another way to do it. So I know an 8-digit HUC. This is my favorite one. It's in northern Utah. It's the Lower Bear River watershed. So when I enter that, and I'm going to go ahead and just get data that's been collected since 2012, then if I scroll down, I've got a couple of different options. I can show those sites on a map. So if I were to click on that, it would show me where those things are on a map, which I could then interact with. I'll go ahead and do that, even though this might take just a second to do. So what it's doing right now is it is going out to the portal and it is querying based on my input parameters, and it's saying within that 8-digit HUC that I was looking at, how many sites will be returned. So it says there's 131 sites. So I'm going to go ahead and hit continue. And what it's going to do is it's going to come back and it's going to draw those on a map for me. And this tends to take just a minute or two for it to draw it on the map. The actual retrieval of the data is often a little bit faster than this. And then when it's done, what it'll do is it'll put it on the map. There they are. And I will zoom in. Just so you can see those. So those are every single one of those dots that you see is a water quality monitoring station, or it's a location where data have been collected. The blue ones are coming out of the STORET system, or EPA, data that's been shared with EPA. The green ones are USGS collected data. And what I can do is I can click on any one of these dots, and it'll tell me a little bit more about that site. So this shows me that this one here is a USGS site, or I'm sorry, this is there must be two sites there. So there's a USGS site and a Utah DWQ site, and I can download data from those sites as well. So I could just download that data directly from here, and I would get all of the data for that particular site. Because I don't want to do this on a one site at a time basis, I want to download all of the data for that area. I'm going to come down to this next section where it says select data to download. So I've got different options for downloading data, and I'll describe what each of these mean a little bit. So if I just want the sites and their location, I would choose this site data only. So what that's going to give me, it's going to give me the site identifier, it's going to give me the name for that site, and most importantly, what it's going to give me is the latitude, longitude coordinates for that site. So the whole purpose of getting this data download is to be able to put it on a map. That's really the main driver of downloading this file. If I hit download, it's going to, again, go off to the portal. It's going to ask it the question, how much data am I going to get? And I'm going to hit continue. And it's going to come back to me as a comma-separated file. So that's going to take it just a second to grab it. You can see down here at the bottom of my browser, since I'm using Chrome, that's how Chrome deals with it. I open up that zip file. And what you should see when that opens up is this station.csv file. So that's the actual stations file. And I'll open that up in Excel. I should take this just a second. CSV files automatically open up in Excel, which is pretty handy for them. So there is all of the information for the stations. So again, the important things in here are that identifier. So there's that unique identifier for each station, the name for that station. You do have some information about what kind of station it is. And then, like I said, most importantly, the latitude, longitude measures, so that helps you draw it on a map. We'll say, okay, well, that's interesting and that's great, I like that, but what I really want are the results. I want to see the actual raw results. So I've got a whole bunch of different options for results here. And these really are all about how much metadata that you want. And so not to be confused, and a lot of people have been confused by this one right here, this sample results biological metadata. They think that means they're only getting the biological data. It's not true. What that means is that you're going to get all of the additional metadata elements that we have defined for the biological data. So there's a whole suite of additional metadata pieces that go with biological data. So if you choose this option, you're going to get a broader set of metadata. This one here, the sample results physical chemical metadata, is going to give you a little bit narrower set of metadata. And then this third option down here gives you the smallest amount of metadata. So it really kind of can drive how much data you want to get back in your file, or how many columns you want to get back in your file. For me, I almost always will use this physical chemical metadata results file, just because that tends to be the one I'm most familiar with. However, you can certainly play around with any of these, and it really depends on what particular pieces of metadata you're interested in. These other three options are relatively new. They allow you to download some additional information with some additional metadata, so you can get information about the sampling activity. So this would give you more metadata about how the samples were collected. It'll give you some summary level information about the samples that were collected. Metrics is another type of data that is contained within the portal. These are individual metrics that were calculated at each site. For example, if a organization did a whole suite of habitat samples and they developed a whole suite of habitat metrics based on those samples, or they possibly did a whole suite of biological metrics, based on the assemblages of critters that they sampled. This allows you to be able to download those. Not a lot of that data in the portal right now, but we've built that capability for you to download it because there is at least some. And then this last file gives you the ability to download, which is another metadata type file, a more robust set of the result detection quantitation limit information. So it is possible within the portal to have multiple detection limits for each result. And so this gives you the ability to get that entire suite of result detection condition information for all the results. So what I'm going to do is I'm going to go ahead and choose my favorite one, which is this sample results physical chemical. I'm going to keep it as a comma separated file, and I'm going to hit download. So what it's going to do is it's going to again query the portal and tell me, it's going to come back and tell me how much data I'm going to actually retrieve. So it's validating my query. It's telling me I'm going to get a little over 12,000 results from 129 sites, and I'm going to hit continue. And what it's doing is it's going out to the portal now, and it is processing my query. And then once it's processed, it again should return to me this nice little zip file that has my CSV file in it that I can then use to take a look at that data. So it's downloading that file right now. This should only take it just a second. That's not a very large file. There we go. And just to kind of show you what that looks like, I'll open that up as a zip file. There's my result.csv file. And when I double click on that, it's going to open this up in Excel, because the CSV files open up right in Excel. And you will see the actual results that have been collected in this 8-digit HUC since 2012. So here is all of the data. Let's make that a little bit bigger. All right, so you can see all of the samples that were collected, and what I want to do is just kind of scroll over. A lot of this is just metadata information. And then if I get all the way over into here, I will see here is the characteristic that was sampled, and then I should also see the result and the unit. So there's the critical piece of information that's here in this file, and then there is a whole bunch of metadata that describes that particular value that is seen there. So a very simple way to get access to the data in the water quality portal. One other thing that I will point out, this column right here, this monitoring location identifier, this is the same ID that is in that station file. So if you want to be able to join the data together, that's how you do it. You join on this column right here. It allows you to be able to join your results to your locations. Okay, so that is the water quality portal, and like I said, it is a pretty straightforward way to download the data. It's a really great tool for getting access to that information. The last thing that I will show you here, and this is really critical to the portal, and it's really what makes all of our other tools work, is that everything that I just did in this interface, there is an underlying web service that supports that functionality. And so what that means is within the portal, if I click on this button, Show Web Service Calls, it shows me a URL, or basically a web link, that would resolve to that data that I just downloaded. So you can see that here for the results. There's my HUC with its input parameter, that's 16010204, and there is my start date of 01/01/2012. So those were my two input parameters, and if I had put any other input parameters, they would show up down here as well. The rest of this stuff here is really just telling me what format I want it in. So it's telling me I want it as a CSV file, I want it to zip that file up, and this sorted really just tells it don't try to do any extra sorting on it because that will slow it down. So what is neat about this is that I can take this URL, and if I were to just take that, paste it in a new window, and hit return, you'll notice I'm not going to the portal user interface at all. There's my file. So it will automatically go to the portal and it'll return that data for me without me having to go to the portal interface in any way whatsoever. So here's where this becomes really cool from a developer perspective. So for my developers that are out there, imagine what if I could turn this 16010204 into a variable, or what if I could turn this start date into a variable? Then I could give the user the ability to say, okay, give me what one you're interested in, and I could generate this URL in my application, and then I could get a different set of data. So let's say that I wanted it, what I really wanted it from was from the Lower Animas watershed, which I happen to know that one too, which is 14080104. And I'm interested in data that's been collected since the beginning of 2015. So if I do that and hit return, again, notice I didn't have to go to the portal interface at all, just that one change, and look, there is my data. So there would be the data right there for that 8-digit HUC 14080104 that's been collected since 2015. So it's a very powerful way to interact with the data, and again, to be able to build applications to allow you to interact with the data. And if this is the first exposure that you've ever had to a web service, at least from this kind of an interface before, I can guarantee you have worked in web services before as well. If you checked what the weather was today, this morning, on your phone, you interacted with the web service. What your phone basically did is it used your location as an input parameter, and it sent that off to some server that's out there in the internet and said, here is a location, tell me the weather for that location. That server responded back with a file of some sort that your phone turned into a pretty picture of either a sunshine or a rain cloud for you, or a snow cloud, depending on where you're at today, and to tell you what the weather was for you today. So that's a web service, an example of a web service. This is an example of a web service too, and this is a great way to be able to interact with your data dynamically. All right, so hopefully everybody's up to speed with me on that, because that is critical to the Water Quality Portal data discovery tool. So I'm going to go ahead and kind of jump into some of that discussion. So we've been working on a couple of different tools. The first tool is this data discovery tool, and it's really meant to find a data set of interest. It does some very basic QA checks to process out things like duplicate data, data that doesn't have units of measure, data that doesn't have analytical methods associated with it, allows you to be able to deal with the non-detects as well and decide what to do with those. Another tool that we've been working on is the data analysis tool, and again, what that does is it compares the data against water quality criteria or other thresholds. It does some trend analysis. It can also do some metals criteria calculations as well. So it's really meant to help with that water quality assessment process. Part of why we went some of the directions that we did, some of the tools that we used, we decided to use R, which is open source statistical software. It's very powerful. It has a lot of great capability in being able to develop tools. There's a pretty broad user community out there of scientists that are using these tools, so we used R. We also used a part of R called Shiny, which gives us an interface for the R application, so you'll see that when I show you the tool. We certainly did run into some issues in using R, and I'm sure if you are an R developer, you guys have run into this as well, and if anybody has come up with better solutions for this, I would be all ears. But very often the packages get updated. Not only do the packages get updated, but we get new versions of R come out pretty frequently. And we found that even in the middle of our development process, in just a year's time, at the beginning of the year things would work, by the end of the year things wouldn't work because new packages were developed that changed how different functions worked within the system. So our solution for that was to use something called R Portable. that was a very nice solution because it allowed us to be able to package up all of the packages that we used and the version of R that we used as well, and give that out to people in that way so that we always knew it would work and we understood what the environment was going to be no matter where it was. So that was very helpful. It also meant that our users didn't have to have R installed on their computers, so they could, which is helpful if for federal folks, because we don't always have the ability to install a certain version of R or even R at all on our computers. So it's very helpful to be able to have that capability. The web services were super helpful in the water quality portal, and the other thing that really made this all work is that there is a package that has been developed by USGS called the Data Retrieval Package. It's an R package. It allows you to be able to interact with the web services in the portal very well, and it works incredibly well. So that's what made everything work. It's really the guts of why our tools do work the way they do. The reason why we built these, it really comes down to the interface in the portal is nice, it's great, it gives you a lot of capability. A lot of our users, though, were asking the question of, okay, well, so what? I've got this CSV file or I've got this Excel file, now what am I going to do with it? And there was a lot of extra steps that they were needing to do every single time with every single data set to either make a decision as to whether or not they could use that data or what parts of that data they could use, or even understanding what data they had. And so we wanted to develop some tools that would really make that a lot easier for them to be able to understand the data that's coming out of the portal to help them make that next step of, yes, I want to use this data for my decision. In addition, for the data analysis tool, part of our driver there is really around the function of the water quality assessments are a messy process. You've got the concept of the water that you're assessing, and for that water you've got a whole bunch of monitoring locations, and then also for that water you've got uses that you're going to assess, and for each of those uses you have a whole suite of parameters that you need to evaluate the data against. It's a messy process and also very time consuming as well. And so we wanted a tool that could take the monitoring data, compare that against the criteria defined for each of the uses at the assessment unit level, and then give you very quick answers as to which of those parameters that have been monitored are exceeding the criteria in the water quality standards. So that was a big driver for that tool, and it's a very complicated tool because of that, and which is why it's still in beta mode, but we're working on it. Before I jump into the data analysis tool anymore, though, I think what I'm going to do is I am going to demo to you the data discovery tool. So what I'm showing you right now, this is just running on my computer. This is the version of the data discovery tool that is running in R Portable. You can download this off of our website. It's a fairly large download. It's a little bit over 150 megabytes download. Most of that is because of the R Portable pieces. But when you download it and unzip it to a folder on your computer somewhere, you will see there is this .bat file, this discovery tool.bat. That's how you run the tool. All you have to do is just double-click that batch file, and what it'll do is it'll kick off R Portable. It'll load all of the packages that are necessary. If the package isn't there, it'll download it for you. And then what it'll do is it'll start up what will look like a web interface. A lot of people get confused by this. They'll say, okay, well, where's this website? I want to go to this website to interact with this. Well, this isn't a website. This is just Shiny, and it's running locally on your computer. This isn't out on some web server somewhere. It's running just on your computer, and it's running locally on your computer. And what you'll see here, this will start to look a little familiar. This is very similar to what you would see on the Water Quality Portal user interface. You've got the same sort of query capability. I can query by location, I can query by sampling parameter, and I can query by site information as well. We organize it a little bit differently to try to make it a little bit smoother, but you can query it very much the same way. You come in here, and in this case, I'm going to do it by county. So I'm just going to start typing the county that I'm interested in.
And Dwane, this is Adam. We had a couple of questions about the queries that you build during the portal, in the portal. So real quick,
yes.
Can data be returned as a JSON file?
Not yet. Well, we got a technical group of users. Yeah, that's something that we are looking at. There is some JSON capability and some features that, if we have time, I'll show you. We're working on some upstream, downstream search capability. That all gets returned as JSON. But the actual data itself, that does not yet come back as JSON.
Okay, and for hub selection, are you able to use other levels besides 8-digit, like 10 and 12?
We don't support 10 and 12 yet. We're building that. So 8 is the lowest level you can go. You can do 6s and 4s and 2s, but you can't go higher. You can't go at a finer resolution than an 8 yet.
Okay, one more and then we'll save the rest for the end. There was a question about why lat-long data aren't typically included in the sample result.
Yeah, so the reason for that is it's really just a data efficiency perspective. So what would happen is that lat-long would have to get repeated for every single result. That's the only reason why we didn't do it. We get that question all the time, and that's really the big driver. It's a one-to-many relationship there, and so that's why we don't do it, because then you would have that latitude, longitude for every single result.
Thank you.
Okay, so I've got Stafford, which is the county that I live in, and I'm going to say I want the last 5 years worth of data. That last question is a great question, though, and this is the area that the data discovery tool solves a little bit for you. It takes care of that for you, so it actually puts all of that together for you. So I enter my parameters. One thing that I'll point out down here at the bottom, we did this just to kind of show that we're using that same technology. So that is the web service URL that it's going to send in. I hit retrieve data. It's going to go off to the portal for me, and it's going to do the same sort of thing. It's going to check what's the record count, how much data am I going to get back, and it's going to come back and tell me I'm going to get a little over 18,000 records from 54 monitoring stations. I click on that import data. So now what it's going to do, it's going to do two things. It's going to go out and it's going to grab the stations file because it needs the stations in order to put it on a map. And then it's going to also go out and grab the monitoring, the data itself, and it's going to put it together for me. So when I'm looking at it here in this tool, it doesn't care. You don't have to worry that there are two separate files. It puts all of that together for you for the purposes of being able to do your analysis and discovery of that data. So it's doing that right now. This does take it a little bit of time to go out and grab that data. I found that it's always longer than I want it to be when I'm doing a live demo, just because that sometimes takes 20 to 30 seconds, and that's an eternity, and it worked perfectly. So there it is. So when it's done, you get back this data import complete. I hit close, and now I've got data in my system. I go to my next tab, which is a check data tab. It gives me some summary level information. Again, tells me how many records, how many stations, how many parameters, how many of those were non-detects. Also tells me if there were any records that didn't have units or didn't have analytical methods, and it also tells me if there are any duplicates in there. And what it will do is anything that is a duplicate or doesn't have a method or doesn't have a unit, it pulls that data out, just strips it out for you, because you really can't use that data anyway. It's not usable if it doesn't have that information. I do have the option of deciding what I want to do with the non-detects. I can ignore them if I want to. Don't recommend that. Or I can do one of three different things. I could set them equal to the limit of detection. I could set them to equal to half the limit of detection, or I could set them to 0 if I wanted to. This is really just for the purposes of analysis. What do I want to do with that when it starts doing summaries on that data? I'm going to go ahead and set them to the limit of detection for now. I can look at any of this data as well. So this is this all data tab. This is all of that data. I could save this data out, and it would save it as a CSV file for me. I can look at the non-detects. These are all of the non-detects, and again, I could save that out if I was interested. There weren't any without units or methods. There were some duplicates, though, so if I want to take a look at the duplicates, here are all the duplicate records, so it's going to strip all those out for me. And then at the end of that, I get this filtered data set. So this is the data set that I'm going to be using to do my analysis. So this is all of the data that made it through all of those checks, and it includes whatever change I told it to do for the non-detects. The last thing I can do on this page is I can have it create a summary for me as well. So what this will do is it'll go and summarize each parameter at each monitoring location, and it'll give me the min, max, average, and the number of results at that station as well for that particular parameter. So this is a really handy way to kind of summarize all of the parameters that have been collected at those locations over a period of time. So it's a handy thing to have. I could save that out again as a CSV file, and then I could do more analysis. Where we really get power is when we get to this View Data tab. This View Data tab, again, because it pulled all of the location data together with the result data, it gives me a nice little map of all of the stations. These bubbles, the bigger the bubble, the more data are available at that station. What I can do also is I can zoom around here. I can click on any of these. So I could click on one of these bubbles. It tells me what organization is collecting that data. It also will tell me the name of the station, how many samples were collected, and how many results. If I select that station to summarize, then I've got some other tabs here that I can look at. There's a station summary. And what the station summary is going to do is it's going to look at all of the parameters that have been sampled at that location. And it's going to give me a pie chart here that the actual slices of the pie are relative to the number of results for each of those parameters. So this station has a pretty broad suite of parameters that are being collected there. Probably not a lot of results for each of those, but it's a pretty broad collection. And then also I get this time sampling frequency as well, so I can kind of see, well, when were they out there sampling. So it looks like most of this comes from really just one basic sampling event, and then there were a few additional that came at a second sampling event. So about 2 sampling events that happened here. That's not that interesting. Let's go back here and find another one. Let's pick this one here. And again, I can summarize that. This station will again show me all of the parameters that are being collected there. And again, a little bit more dense data there. And I can also look at a parameter unit summary, and it'll give me some nice little line charts for any of the particular parameters that I'm interested in. And I can do up to 3 parameters at a time. So if I want to look at TKN, and let's say, let's do total nitrogen as well. And let's look at chlorophyll A too. So I can look at those 3 parameters together. You can see they pair up fairly nicely together. So you can look at that. I could export this out as a graphic that I could then put in a document or whatever else I wanted to do. Again, the whole purpose of this tool is really just to help you discover your data. You can also start to ask questions on your data too. So let's say, for example, what I was interested in is that I wanted to know I wanted to see all of the places that had been sampled for nitrate. So I can come in here and I can type nitrate in my parameters. So we'll just go with that one. And I hit submit, and it's going to filter my data set. And now what it's showing me are all the locations where nitrate has been sampled. And then again, the bigger the bubble, the more data has been collected there. Let's say what I really want to know is I want to know every place where it was greater than 1 milligram per liter. So I'm going to change that value, and I'm going to hit submit again. All right, so now I've got those 5 are the locations where they've detected nitrate at least greater than 1 milligram per liter. Again, the whole purpose of this is really just to help you understand what's going on in your data. You can do this for any of the parameters that are here, and you can do all kinds of different filtering. You can do filters by sample media. You can do filters by station. You can say, I'm only interested in data that's been collected by USGS. I'm only interested in data that's been collected by the state. I'm only interested in my data. Whatever it is, you can do any kind of filter here. You can filter by methods too. So if I'm only interested in data that used a particular analytical method, I can do that filter here as well. And then what you could actually do is I get a table of this data. I could export this out. And so I could say, here are the 5 data points where it was greater than 1 milligram per liter, including the location as to where that's at. All right, so that's the data discovery tool. It's the capability really to help you kind of discover and find your data. So I'm going to stop and see if there are any other questions about the data discovery tool.
Yes, thanks, Dwane. We've got a couple here. From my colleague Gail, is the maintenance and progress of the portal at risk with proposed federal budget cuts to EPA and USGS?
Great question. And the best way I can answer that, because our budget's a little bit unknown because we're functioning under a continuing resolution through December right now. From a agency prioritization perspective, for our budget that we're looking at, the line item that we set aside for the portal is our #1 priority. So meaning even under pretty draconian budget cuts, that still gets funded. So for us, it's a critical piece of infrastructure. So I'm hoping that answers your question, and that's probably about as clear as I can get on that.
Let's see. I believe you answered this. Is there a way to evaluate how many samples were in non-compliance with state water quality standards? And I believe you showed a way to filter for parameter ranges. Is that the best way to accomplish that?
Yeah, so that's a great question, and that's really more of a function of the new data analysis tool. So that's what that tool will do, is it'll compare that data against this water quality standards, and then it will give you those statistics, how many that were actually in exceedance of a particular standard.
Okay, and then we have a couple other questions about the types of data in the portal. Is macroinvertebrate data in the biological data section, and are there other non-water chemistry data in the portal, like temperature?
Yep, there's definitely temperature data. There's a lot of temperature data in there. Biological data, there's some. It has the ability to support it. The challenge that we've had is getting that data shared. So there's not a lot of, we don't have a lot of the macroinvertebrate data. There is some fish tissue data in there. Again, not a lot of it compared to the physical chemical data. And then there is some fish count data in there as well.
Okay, and a couple other good questions, it looks like. Is there a way to filter data by month or season?
There is not. So you couldn't, right now we don't have that capability to do it by season. You can certainly select the dates that you're interested in, but you couldn't say I'm interested in just data that was collected between March and May of every single year over a time period. It doesn't allow you to do that. However, the one thing that the data analysis tool does do for you is that it will do a seasonal trend analysis for you, which kind of gets to that functionality, or at least why you would want to do that. So it will do, at least that tool does do a seasonal trend analysis.
There was also a question of your computer resources. How much hard drive or RAM space is needed to run these tools locally on your computer?
They're pretty minimal. So in terms of hard disk space for the data discovery tool, once you unzip that file, I think it's about 400 megabytes in size. In terms of memory resources, most modern day computers will be fine. I think as long as you've got a couple gigs of RAM, which is pretty typical in computers nowadays, you probably will be fine. They will work on either a Mac or a PC. The one thing about the Mac, though, is that there isn't an R portable for Macs, and so what you have to download is just the R scripts themselves and run it in R instead, which is fine, and it works, but you just can't use the R portable version, and you do have to have R.
Okay, and two more good questions. Do you have a prospective timeline on when 10 and 12 data queries will be available?
What we're hearing from USGS, who does most of our development work, because we need it for another tool that we're developing, is they're hoping by December, which I would say that probably means January, just knowing schedules and all the other things that are in the hopper. But we're hoping by at least January we'll have that 12-digit capability.
Okay, and looks like we got one more, and you're going to like the next one, so we still have two. Is water quality portal receiving much continuous monitoring data?
Yeah, there is a little bit in there, and what I'll tell you is that it's honestly not designed for the continuous monitoring data. So what I'll say in that regard is that the data models for continuous monitoring data and sample data really are different. Sampling data is more of a horizontal structure. You've got one result with a bunch of metadata, whereas the continuous data is really more of a vertical structure where you've got some metadata that describes a whole bunch of results. So there's a different approach that needs to be taken with that. We're working on that. We had some pilots. Be happy to have a future discussion on that about how to properly share the continuous data, some exciting things going on there. But we're probably a year or so away from being able to really have that more of a broadcast open tool that people can use.
Okay, and then the last question, which I think also sets you up for some future work you've got coming. Attains will have a connection to link segment status with monitoring data someday. Do you see an integrated Attains portal system?
Yeah, so we're actually working on that now too. We are working on what we're calling, it's a rebrand of the How's My Waterway app. So if folks have used How's My Waterway in the past, it's a redo of that. We're calling it How's My Waterway 2.0. And what it basically does is it pulls in data from Attains, Water Quality Portal, our ecosystem, the 319 program, CIDWIS. We're actually had some discussions with our National Estuary Program today as well. And basically what it does, it pulls all that data together to tell one common story at a 12-digit HUC level, at a county level, at a statewide level, and at the nationwide level. So it provides kind of a one-stop shop to be able to pull all of this information together, and we're having some initial discussions about also how to pull in local information like cleanup activities that watershed groups are doing, and being able to pull that information into that story as well, which we're really excited about. So yeah, that's under development right now. Probably should be able to hear more about that sometime in January, and we are hoping to do a demo at River Rally.
And I will say I've seen a sneak peek of that, and it looks pretty sweet. So, well, I think that's about it. I just posted a link to our webinar survey on SurveyMonkey in the chat box. So please do visit and complete the survey. If you don't get it there, we of course will also send you a reminder to complete the survey in about 24 hours time. If you enjoyed this, please let me know. If you have other ideas for topics you'd like us to tackle, please send them my way as well. I hope you guys enjoyed the webinar, and Dwane, I want to say thank you for all you are doing and for presenting for us today.
It's my pleasure, and I did want to put up on the links to all of these tools so folks can download them as well, both the GitHub links and the web links to the data discovery tool in the portal, so folks can have that as well.
All right, great. And with that, I think that wraps it up. So I want to thank everyone for joining us, and I hope you enjoyed the webinar.
Thanks, Adam.
All right, take care, everyone.